program tai ka chhe desu ki C programming 8051 using C programming. Like this type of question. See, write an 8051 C program to toggle bit D0 of the port P1. Okay, pin number P1.0, port is port P1, 50,000 times. Okay, 50,000 times. So see, we made a for loop here where it will start from Z. Okay, this is a condition, this is the limit of the loop. So since this is 50,000, so Z should be less than equal to 50,000, Z plus plus. And what we need to do, we need to toggle means 0 to 1, 1 to 0, right? So I'm just toggling which pin P1.0 by assigning my bit to P1.0. Okay, so this is the keyword here. S bit keyword allows access to the single bits of the SFR register. So if you are using single bits, then you need to specify this keyword or syntax. And this we need to equate P1.0, we need to equate by anything, like for example here a user defined function or user defined value is there, that is called as my bit. So my bit will be either 0 or 1, it will be toggling. Okay, this is one program. Okay, see from where we stopped last time. Did you see this program, Nini, last time? Write a 8051 C program to send hex values for ASCII character of 0, 1, 2, 3, 4, 5, A, B, C, D to port P1. Okay. So Ebdaro will start will open a for loop. Here for loop, this Z is not a variable to count the number of counts here, but here this is the number of ASCII characters in this case. Okay, why it is an unsigned character, my num, this one, because there is a content of ABCD, that's why. See, C compiler use the signed character as the default if we do not put the keyword unsigned. So even if I don't put unsigned, by default 8051 will understand that it is a signed character. Okay, see, this is another way. Remember this, for hyphen, right? Hyphen, no, a semicolon. You remember, right? For loop gari dini na shego C programming na shedo mate. I hope you have studied somewhere. Sign character is an 8-bit data type. Use the MSB D7 to represent minus or plus. Give us values from minus 128 to plus 127. Okay. So minus 128 to plus 127 is the range. So till that values, this sign character can give. We should stick with the unsigned character unless the data needs to be represented as signed numbers. Okay, what is example? Temperature. Like, so temperature cannot be negative, right? Can it be negative? Temperature. To send values of minus 4 to plus 4 to port P1, how you will do? Yeah, this question. So minus 4 to plus 4 beodalo. So minus 4, minus 3, minus 2, minus 1. Okay. And plus 4, plus 3, plus 2, plus 1. So there are 8 characters, right? Including 0, I think it is 9. So overall right now it is 9 actually, but we'll discard 0 and we are trying to bring, right, one by one by defining a thing called minum here. See, and the last line the little confusing, you must be wondering why this last line. So this last line is the one which makes this C programming more unique. Otherwise, we don't write this kind of syntax in microcontroller. 8051, a assembly language, I mean. So this is for sign number, so it's a main function. Character minum. See, always we need to open like this. Okay, character minum, brace brackets, 8 numbers from minus 4 to plus 4. Unsigned character set. It can be a signed character also, it doesn't matter. But let's write unsigned character because it's a standard one. If you don't write unsigned character, this set number will be taken as signed characters. See, we should stick with the unsigned character unless the data needs to be represented as signed numbers. Okay, and another feature of signed characters is an 8-bit data type. Okay, see, unsigned character has a range from 0 to 255. Signed character will have the range from minus 128 to 1 plus 127. Though it is slow, minus 128 to plus 127, the number of data range is 255 only. Because minus 28 plus 127 255 range. But it has gone to the negative side of the integer. That's why it is a signed character. Okay, so this is important. This part is important. So if the data range is beyond 127, then you need to use unsigned character. Otherwise, signed character will also work. Similarly, unsigned integer, signed integer. See, signed integer is from 0 to 65,535, and signed integer is minus 32,000 to some values to plus 132 7 plus 37 32 7 767, right? So these are for integers and characters. These are for single bit. See, these are single bit instructions. See, unsigned integer and signed integer are 16-bit instructions. Okay, these are 16-bit instructions. These are 1-bit instructions. Special function register bit addressable only and RAM bit addressable only. SFR, another one data type is also there, which is of 8-bit. Can occupy the RAM address from 80 to FFH. See? So the bit data type allows access to single bits of bit addressable memory. Space is 22 to FH. To access the byte size SFR register, we use SFR data type. Byte size SFR registers. See? There are two ways to create a time delay. So time delay is one important aspect in microcontroller microprocessor. So you need to understand little bit, at least little bit, not in depth as compared to 8051. How do you accuracy of the delay? If the compiler is very fast, it's very effective, then the accuracy of the delay will also be improved. For example, this program, to toggle bits of P1 continuously forever with some delay. Okay, so we need to toggle the bits of P1 1 0 1 0 1 0 toggle P1 bit forever given. It is for forever and with some delay. And with some delay, that means 0, when it stays for 0, it will stay for some time. When it changes to 1, it will stay for there for some time. So how do we need to do this? Okay, P1 0x55, we need to put like this, right? Toggling cell of the 55 the AA. Why 55 and AA? Why 55 and AA? Why 55 and AA? What is AA? What is 55? 55 is 0 1 0 1 imo. And remember AA is 1 0 1 0 1 0 1 0. So this is just opposite of this one. So this value is toggling to this one. That's why these two values are easier to show. That's why most of the time we use this one. Though you can use this one also. This one also. This is also opposite to one another, toggling. But you know, most of the time we don't take 0. That's why. In order to execute some meaningful programs, we need to have some values like this. Are you getting? Why always they are taking 5, 5 and AA? Yes or no? Only 14 of you are there, huh? So how do you do this? See? Unsigned integer x instead of character, unsigned character x, int x. Okay? Why? X is a number right now, right? It is not alphabets. If there is alphabet, then character. ASCII code character. So for always when you are repeating forever, you need to put this to semicolon. Semicolon, right? What is this punctuation mark? Love me. Hello? Sleeping or what, everyone? Ishen disu gale? Ishen disu. Tenzin, Chong, Ugen, who all are not there? Teme. Teme. Today is 18, no? 18 to... Yeah. Sonam?
Present, sir.
Kelzang?
Present, sir.
Roshan?
Present, sir.
Wang? Chong Doji? Doji Gelchen? Tenzin? Namit?
Present, sir.
Chenju is not there. Ugen? Ugen? Rajesh?
Present, sir.
Samjana?
Present, sir.
Sir, Sevamdoji present, sir.
Chong Rinjin. Not there. Chong Dorji is present. Punam. Not there. Kencho.
Present, sir.
Sharap Tenzin. Not there. Kinle. Kinle Chiring. Kinle Namge Chiring. Nim Chiring. Not there. Kinle. Kinle Wachu. Kale Kinle Wachu. Kinle Wachu is not there. Ugen Wachu.
Present, sir.
Karmawandi.
Present, sir.
Sonam Yezer. Yezer Mindumo Yezer ya. Gaki. I think she is there. She came first. Yeah. So we'll come back.
Present,
Taru.
sir.
Yeah. So whenever you are trying to make an infinite loop, repeat forever, okay, for two semicolons like this, okay, two semicolons. Delay, if you want to put a value in a port, okay, if you want to put a value in the port, you can't write directly, like for example, P1 equal to 55 se dimage ho. You have to write 0x55. Okay, are you getting? 0x55. So see, this is the size of the delay. So after, okay, within this loop, first P1 will take the value of 55. Okay, then it will take a loop of 40,000. So it will remain for 55 for 40,000 loops. You imagine then how much time it might require. Again, after 40,000 loops, it will change to A. Okay. Are you getting? After 40,000 loops, it will change to AA. Then after that, it will change to again delay here. 55 will remain for 40,000 loops, then it will change AA, Daru, it will remain for 40,000 loops again. That's what it's saying right here, Anam. Make a delay between them, but for forever. That's why this is inside another loop, Daru, which is a forever loop. Did you understood this program? Very simple program. 40,000 they have taken randomly here on a loop. See, for so you don't any loops ki time delay the time delay calculations we have done actually in assembly language. We have done, right? Remember, right? Assembly language na lo time calculation cheriega. assembly. So we have done some time calculation, delay calculation for assembly language. Okay, but in C programming will not, for you it's not there. Okay, actually these portions are not that much in depth in your syllabus, but C programming 10 say brother in the syllabus. Please check your syllabus. Okay, Analu, they have specified, see, if it is for 250 millisecond, then you have to write, you can specify directly like this. This is the advantage of C programming. But in assembly language, you cannot write this program like this directly. If you want to have a delay of 250 millisecond, then you need to calculate each line की machine cycle कम mo, each line की delay कम mo, then only you can make a conclusion. Are you getting? See, let's see, Analu, main function, see, P1 0x55, you put a delay. How much? 55 will remain for 250 millisecond. Okay, then it will toggle P1 0x4 AA. Then it will remain for another 250 millisecond. Imagine. No? 250 millisecond. So this is, please note this, okay? This is the most useful robotics nullifier. This it uses a lot this technique. Light on, okay? Let's say this is for light on, this is for light off. If you want to make the light on for 250 millisecond, then okay. Now this one, see this part. Why this part is before this, Analu? So this is the main program, yes, no mush. But before it runs this program, first function will be this one. Now what is this? This is the delay they have given here. See, Analu. What is the delay about? Unsigned int, just randomly they have given some, they have created a for loop here. So before running this program also, they have provided some delay, some kind of a delay here. Are you getting or not? See, LEDs are connected to bits P1 and P2. Write an 8051C program that shows the count from 0 to FFH. Okay, so this is some kind of a header file you need to understand. Like for example, if 8051 8052 if you are connecting to as an output port, then you need to call these header files. These are important. So void main, see, P1 equal to 0 0. We are clearing all P1 port. LED clearing P2 port, because in P2 LED is connected, right? P1 is actually the input port. Analone, there is a mistake here. P1 is the input port. So both we need to increment, right? Analo, right? And ATP that count from 0 to FFS. See, it need to increment from 0 to FF, right? So that means what is FF? FF is 8 bits memory. So it need to start incrementing from 0 to 1111. How you will do? You'll just increment P1 plus plus LED plus plus, right? Like this. Both I need to increment. But this one also, this should be within a forever loop or no. Then it will go on, see. Program after program is there, will not finish. Okay, I think you must have got some idea how this in C programming it is used. Sabji ka idea thi.
Yes, sir.
Wait. Wait. I'll show you one program of LED interface. No, not this program. They may. Okay, it's okay. I'll try to do in the next session. For today, it's okay. You try to see other programs also, okay, Anale? Simple programs. From using C, there might be a simple question, not that lengthy, but a simple, 1, 2, 3 marks, 2, 3 marks maybe, or maximum 5 marks. As 8051 using C. Wow. Punam is present. UP, Kali UP present. Okay.